Hello everyone. So yes, I'm ABDUL-HAMEED. So today we're going to talk about partial functions, right? So what are partial functions? So normally when we talk about a function, right, a function is basically a form of a transformation, right? So it takes a value from a domain and it puts a value in the codomain. So normally the way we visualize it is it's like a machine, right? So let's say you want to make condo, right? So condo, you need corn, right, which is like maize. So you have to peel off the maize and then pour the maize grains you get, you pass it into the machine, and then to bring out the condo. So the input is the maize you are putting in, the maize grains, and the output is the condo, right? So if that's what the function does, basically, it takes some input, processes it, and gives an output, right? So, and that's what it gives functional, a function, right? Now, the idea is for every function, right, there is a set of appropriate inputs that you can give to the function for which the output of the function is defined or makes sense. So the set of all inputs that is allowable to be passed to the function in question is what we call the domain, right? Then the set of all outputs that can come out of the inputs being passed to the function is what we call the codomain, right? So domain and the codomain. So when you have a function, right, ideally the idea behind the function is it is defined for all elements of its domain. But then there was a bit of a misnomer, right, when it came to description of functions in the computer science, right? So we had something called partial functions, right? So partial functions, they are functions. Ideally, functions should be defined for all elements of their domain, right? But then in computer science, they have something we call a total function and a partial function, right? A total function is defined for all elements of its domain, right? But then for a partial function, it's only defined for certain elements of its domain, right? So for a total function, you can, for example, let's say a total function takes an integer, right? You can pass any integer, negative, positive, zero, whatever. Like you can pass it to it because it accepts it's a total function. But when you build a partial function, then you need to find a way to filter out the inputs that don't give a reasonable output for the partial function, right? Good. So today we are going to go through that example, and I want to show you how to implement a partial function in C++. So in Scala, right? Scala was built by Martin Odesky. It's a programming language. It's sort of like an easier version of Java, so you don't have to do all the nasty syntax of Java, right? Um, Scala makes functional programming very easy, and there is out of the box a object called partial function in Scala that allows you to implement partial functions, as I said, right? So in that implementation of partial functions, there are two main methods, right? So we have the apply method, which is going to be called when we take input from the user and we have to evaluate it, right? Then we have the is defined at method, right? So anytime you take an input, right, you have to filter whether the input is defined to be operated by the apply function or not. So you will define the category or the condition for validity of the values that you are passing from the domain in the is defined at function. Then the apply is what is going to be what's called to do the evaluation, right? So we're going to do that, right? So that's the basic understanding of what functions are. We have partial functions. Partial functions are defined for only elements of certain elements of the domain. Certain elements of its domain cannot be operated on it. So that's why it's called partial. Then we have total functions can be applied for all the elements of its domain, right? So before we begin any coding, let me change the name. It's a bit of a change to be in the name. So, right? Good. So we have to implement these two methods. Okay. So we're going to implement these methods. But before we proceed, let's ensure our environment is run. Let's change. So we are running on Windows right now. Let's change 64 bits. Let's make it a release so that it's faster and there's better optimization. and let's build, right, to ensure that our system is working, right? It runs. You see, start without debugging, right? So it's building. Cool. So it works. So you have the hello world here. Neat, 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 neat. So let's continue. So the first thing we have to do is we have to define a class that will be inherited by all classes that need to implement the partial function interface, right? So the partial function in itself is not an object of its own, right? It will be sort of an abstract class, right? That will implement certain methods, and any method that wants to implement a a partial function will need to inherit that class and then implement or define the apply and is at defined methods of its own choice. Okay, yeah. So let's do that. So let's come here, source file. Let's see, add, and we see. And remember, you can do this one is cross-platform, so you don't need to be specific to Microsoft Windows, Mac, or Linux, right? This can be for every platform. Right? So you say new item. So let's go the source file. We want the header file, okay? So we're going to define something. So I'm going to call it partial functions dot hpp, right? Partial function dot hpp. Okay, correct spelling. Add, right? So partial function dot hpp. So first thing, we're going to include it. So it's a header file. I wanted to make it a source file, but then the source file adds their own complication. We don't want to go into that. So I'm going to make it just a header file so that we can just include. Right. So hashtag pragma once, right, to ensure that when the header is included multiple times, we don't get name conflicts. Because when you include a symbol twice, then when the compiler is like generating the source code, right, it's realized that there are two definitions of a function, right, with the same name in the same source file. So, and even sometimes, even if there are different source files, you can get naming conflict. So we have to put the hashtag pragma once to ensure that it's not repeating the includes, right? So first thing, we have to include optional, right? The optional header file. Why do we need this? We need this because remember, as we said, our partial function for certain inputs shouldn't return a value, right? So how do we encapsulate the act of not returning a value, right? So that we have a single function definition when the value we pass in is defined given the condition, then it should evaluate to a value. But then if it's not defined, it should evaluate to nothing, right? So the way we do that is we give an optional. Then we can put an if to check if the optional has a value in it. If it has, we retrieve the value. If it doesn't have, then we do something else or print something to the screen. Okay. So let's define our class. So our class is class partial function, right? So we're gonna do some templating here, right? Templates. So remember, this partial function, it has its own return type and its own argument type. So we have to add a template, right? So see type name, return type, and we see type name, argument type, right? So we have that. So that way, when you call your partial function, you have to pass it a type name of the return type of the function you want to implement, and then the argument type, right? And then the first thing we have to do is we have to implement a constructor, right? So partial function, right? Default, exactly. So we are implementing the constructor. It doesn't take any input, and remember we have to make it public, else it should not be seeable from outside of the class, right? So you have to make it public. Okay. Then we define our destructor. So normally it makes sense to define your constructor, your destructor immediately after your constructor, right? Because it gives the person a view of like what you're trying to do, right? So you say implement a virtual constructor. It's a good idea to implement virtual constructors because they save you a lot of problems. Let me just say that. When it comes to obtaining, so for example, sometimes you might want to create a variable whose type is the base type of a derived class. So if you want to delete a, a derived class from a pointer to its base class, then you have to declare the base class constructor to be virtual. If you don't do that, it will only call the destructor for the base class and then leave the destructor for the derived class, which will cause a resource leak, which you don't want. So it's always advisable, right? If you are implementing any form of polymorphism, whatever class you have as a base, you have to declare it as virtual. Okay, so let's define our method. So we're going to have the apply method. The apply method is going to return an optional, right? An optional of the return type, because that's the data we are going to return, right? And it's going to be called apply. It's going to take um, an argument type, a constant argument type, right? So arg. And then right now, since we want to make it an abstract class, right, we have to first make it virtual, right? And then make it return some nonsensical value, right? Null option, meaning that if you don't implement it, it will immediately return a null, right? Irrespective of what the value of the argument is, right? Then we have a virtual std. Sorry, we have a virtual bool, right? So is defined at, and then it takes an arg type of a constant arg, right? Then it returns false when not implemented, right? Then after we implement this, remember to invoke a class as if it's a function, right? Which we call a functor. You have to overload the braces operator, right? So let's overload the braces operator. So we say std optional, right? Arg type, no, return type, right? And then we have a operator, right? And then it takes arg, a constant arg type reference, right? If you have a choice in C++ to choose between a pointer and a reference, most of the times you are advised to use it by reference, right? Which is like the type C way, right? Yeah. If you can choose not to use pointers, don't use pointers. But then probably if you're implementing a C++ wrapper to a C library, then you'll be forced to use pointers. Then pick the value, maybe if it's a struct or some huge object, pick it by reference, and then instead pass a pointer to the object to the class internally. So your external interface doesn't expose any form of pointers, right? So that you only manage all those pointers internally from within your function. Okay. So it's gonna be simple. So if, right, if is defined at, if is defined at, right, then you pass the argument, then it should return apply of the argument, right? So if this is defined, right, it's evaluated on the argument and it returns a true. That means that it is a variable that evaluates, right? It is a variable that is in the domain of the partial function. Then apply the method to it. Else, just return an std null option, right? So that's it for this, right? So that's our interface, right? So whatever function we are going to implement, which wants to implement a partial function, has to implement this interface, right? Now, if we don't override the methods, right, by default, they all return invalid values by default. So they will always fail, right? So that will force us sort of to implement it, right? So let's go, let's add a new item. So we say, how do I put it? So we say, let's call it square. So for example, square roots, right? Square roots are the special type of functions that don't accept negative values, right? So that means that a square root is sort of a partial function over the domain of integers because it's only defined what the domain of real numbers, because only defined for positive real numbers, right? Not defined for negative real numbers. So let's put in a condition there. So come here. So let's save here first, right? Let's open here, and then let's do the same thing here. As I said, I'm keeping everything as a header file so that we don't struggle with compilation and moving stuff around. So you see hash include optional. That's the only header we want here. And then the other header we want is included in our directory, which is partial function.hpp, right? So let's define our class. So our class square root, right, is going to inherit from the partial function interface, right? Okay. If you want, right now, square root accepts double and return a double, right? Because we are going to use the C library math function. So we say C math, good. So we have to pass. So it's going to return a double. It's going to take a double. Okay, good. So now let's define our constructor. Right now, our constructor doesn't take anything. So we'll make it a default constructor. I'll talk about it later, but then we have like 4 different types of constructors, right? We have the default constructor, you have the move constructor, we have the copy constructor, and the non-default constructor, right? So we'll explain that later, probably in another tutorial video, right? So let's implement. So the function, the overloaded function, we don't want to override it, right? Because we don't really have to change anything, right? The only thing we have to change is the apply and the is defined at, right? So let's do that. So let's come here. Sorry. Let's come here. So let's say std functional. Hey, sorry. Std optional. It takes a double because it returns a double. And then you say apply, right? Then it takes a double, constant reference to a double, argument type. Then we have to override it, right? Because remember, as I said, remember, right? Remember, as I said, right? It's not supposed to show errors. Don't worry about it. I'll figure out later. So let me see what's happening. Okay, so the optional return type, arg type, const, arg. Yeah, not supposed to complain. But anyways, let's just proceed. Okay, so the apply method, right? So right now, I'm just gonna call. I'm gonna return power of the arg passed, right? 0.5 because 0.5 is the square root, right? So power of arg, right? So let's implement the is defined at method, right? We are going to override the base class is defined at method. So double const arg, right? Override, right? So it should return if arg is greater than 0. So for whatever value you pass in, whatever double position floating point you pass in, you should check if it's greater than 0.0. Let me make it so that it's declaration of intent, so that we know that we are dealing with doubles, right? Then let's come down here, right? So this is all we have to do. We have to override the apply method on the partial function class, right? Abstract class, and we have to override the is defined method on the partial function class, right? And we are done. Okay, let's open our main file and let's include square root.hpp, and then let's include the optional. Okay, so you want to need it, right? We come down here, go down here, right? So let's see auto return. So let's say auto results is equal to, right? Now let's first define the square root object, right? So square root sq, right? Uniform initializer syntax, doesn't take anything. Right, you come down here, you see square root dot, what is going on? Oh, I forgot. As I remember, I said defined all your methods are public so that they are seeable from outside the class. Okay, good. So you have square. So you have sq dot sq dot no sq. Then we pass in the value. So let's say 144.0, right? And we say auto result is equal to, what is happening here? Okay, I think we can fix this problem by going to let's click here, going to properties. Okay, properties, if I remember correctly, I have to go to source explorer. Okay, so we have to go here, and okay, let me put it here, and then let's see properties, right? Let's go to C++, command line. Okay, all options. Let's go here. The C++ standard, we don't want ISO, we want C++20. So let's change it here. So apply. Okay, so it should keep quiet now. Stop disturbing us. Good. So apparently the default language, right? C++ version was C++14, and C++14 doesn't have the implementation for std optional, right? Std optional was implemented in C++17 for the first time. Okay, so I had to correct that. That's why we're seeing the red squiggly lines all over the place, right? So square. So if you highlight it, you see that it's an std optional, right? So we'll check if result does has value, right? Evaluates to true if there's a value in it. So if there's a value, just print the value to the screen. Result dot value, right? Then right, and let's come down here. Stdc out. Or let's make it simple. Let's make it simple, right? We say stdc out, right? That's what I like about C++. It's really sweet. Value or, right, 0, right? Std and L. So we know it should come out as 12, right? 12.0. But then if there's no value in it, then it will come out with a 0. Okay. Or if you want to even make it crazier, let's just make it -1. Right. So fingers crossed. Ha ha ha. Let's run it. So start without debugging. Okay. Generating code. Good. Do you see that? So right now, having that partial implementation, then we can use this header file we've implemented, and then we can we can inherit. So anytime we want to create a new partial fraction, we just have to inherit from this class and then define the apply and its defined methods, and automatically, right, we have a function method that is callable and that filters out the values of input it takes. Thank you very much for listening. I would like you to comment on the video. I'll leave a link in the description to my GitHub repo where I've uploaded all this code. And thank you very much, and I'm really grateful. Bye.